इस लैग्रेंजियन पॉइंट्स के कुछ फायदे होते हैं, जैसे हम यहाँ आदित्य L1 के बारे में बात कर रहे हैं
के कुछ
तो यह फायदे होते हैं, जैसे हम यहाँ आदित्य L1 के बारे में बात कर रहे हैं तो यह अंतरिक्ष यान लैग्रेंजियन पॉइंट बिना के पास जाएगा और यहाँ रुकावट ऐसा पॉइंट है देखा जा सकेगा, ऐसा पॉइंट है जहाँ से सूर्य को बिना किसी ग्रहण या रुकावट के निरंतर देखा जा सकेगा और अध्ययन किया जा सकेगा। विश्लेषणों के लिए किसी भी तरह की दूसरा फायदा यह कि विभिन्न मापन या विश्लेषण न होने के लिए किसी भी तरह की रुकावट या कमी नहीं आ जा सकेगा। वायु न होने की वजह से इस वेधशाला को रखने से दूर तक स्पष्ट देखा जा सकेगा। उपग्रह लगभग लैग्रेंज पॉइंट पर इस वेधशाला को रखने का मुख्य कारण यह भी है कि यहाँ उपग्रह लगभग स्थिर रहेगा और उपग्रह के अभिवृत्ति नियंत्रण के लिए अधिक ईंधन की आवश्यकता नहीं होगी। वर्तमान में PS4 चरण का कोस्टिंग फेज जारी है। वर्तमान में यान की ऊंचाई 280 किलोमीटर जारी है तथा सापेक्ष गति 7.8 की ऊंचाई 280 किलोमीटर तथा सापेक्ष गति 7.18 किलोमीटर प्रति सेकंड है। पुनः प्रज्वलित किया जाएगा। अब यह उचित अभिवृत्ति प्राप्त कर पुनः प्रज्वलित किया जाएगा।
Vehicle performance normal.
The Aditya-L1 spacecraft carries 7 payloads to observe the protosphere. The Aditya-L1 spacecraft carries, which is the outermost layer of the sun. These payloads use electromagnetic, particle and magnetic field detectors. First among the four remote sensing set payloads is visible emission line chronograph (VELC), which is a prime payload designed as a reflective coronagraph with a multi-slit spectrograph. This payload is developed jointly by Indian Institute of Astrophysics, Laboratory of Electro-Optical Systems, UR Satellite Center, ISRO Inertial Systems Unit, and Space Applications Center. The second payload is solar low energy X-ray spectrometer or SOLEX, designed to measure the solar soft X-ray flux to study solar flares. This payload is developed by UR Satellite Center. Third payload is the solar ultraviolet imaging telescope suite, which is a UV telescope to image the solar disk in the near ultraviolet wavelength range. The payload is developed by Inter-University Center for Astronomy and Astrophysics, Pune, LEOS, URSC and IISU. The fourth payload is high energy L1 orbiting X-ray spectrometer or HELIOS, developed by URSC. Is a hard X-ray spectrometer designed to study solar flares in high energy X-rays. The fifth payload is the one which is meant for in situ observations. This is Aditya Solar Wind Particle Experiment, or otherwise called as ASPEX, which comprises of spectrometers to measure low energy particles and high energy ions. This payload is developed by Physical Research Laboratory. The sixth payload is Plasma Analyzer Package for Aditya, in short PAPA. It is designed to understand the solar winds and its composition and perform mass analysis of solar winds. This payload is developed by Vikram Sarabhai Space Center. The seventh payload is a magnetometer or MAG developed by LEOS, which will measure the low intensity interplanetary magnetic field in space using a pair of magnetic sensors.
जी हाँ, आदित्य L1 उपग्रह में नितभार के बारे में जानते हुए इसमें सुदूर संवेदन नितभार हैं और यथास्थिति प्रेक्षण नितभार लगे हुए हैं। सुदूर संवेदन नितभार में सूर्य का प्रेक्षण करने के लिए VELC कोरोना प्रतिबिंबन और वर्णक्रम मापन के लिए है। सोलर अल्ट्रावायलेट इमेजिंग टेलीस्कोप जो कि संकीर्ण और ब्रॉडबैंड फ्रीक्वेंसी में फोटोस्फीयर और क्रोमोस्फीयर प्रतिबिंबन यह पैराबैंगनी प्रतिबिंबन टेलीस्कोप है। इसी क्रम में अगला है SOLEX, सोलर लो एनर्जी एक्सरे स्पेक्ट्रोमीटर, जो कि सॉफ्ट एक्सरे वर्णक्रम मापी है, जो कि सूर्य के प्रेक्षण के लिए प्रयोग किया जाएगा। इसमें HEL1OX हाई एनर्जी L1 ऑर्बिटिंग एक्सरे स्पेक्ट्रोमीटर है, जो कि हार्ड एक्सरे वर्णक्रम मापी है। इसकी अभिकल्पना सोलर फ्लेयर के अध्ययन के लिए की गई है। यथास्थिति निदभार में आदित्य सोलर विंड पार्टिकल एक्सपेरिमेंट, इसका उद्देश्य है सोलर पवन, सौर पवन में भारी आयंस, प्रोटॉन्स और अल्फा पार्टिकल का विश्लेषण करना। अगला है प्लाज्मा एनालाइजर पैकेज फॉर आदित्य। यह भी सौर पवन में उपस्थित कणों में इलेक्ट्रॉन और भारी आयंस की दिशा के साथ विश्लेषण करने के लिए इसे बनाया गया है। एडवांस ट्राइएक्सियल हाई रेजोल्यूशन डिजिटल मैग्नेटोमीटर, इसे त्रिअक्षीय चुंबकीय क्षेत्र के यथास्थिति मापन करने के लिए बनाया गया है, और ऐसे 2 समुच्चय लगे हुए हैं इस उपग्रह में।
Vehicle performance normal.
यान पूरी तरह सामान्य, सभी तंत्र सामान्य रूप से कार्य कर रहे हैं और यान अपनी उद्देश्य कक्षा की ओर बढ़ रहा है। आदित्य-L1 के निदभार इसरो व अन्य वैज्ञानिक संस्थानों के साथ मिलकर तैयार किए गए हैं। विजिबल एमिशन लाइन क्रोनोग्राफ VLC इंडियन इंस्टीट्यूट ऑफ एस्ट्रोफिजिक्स बेंगलुरु द्वारा तैयार किया गया है। सोलर अल्ट्रावायलेट इमेजिंग टेलीस्कोप सूट इंटर यूनिवर्सिटी सेंटर फॉर एस्ट्रोनॉमी एंड एस्ट्रोफिजिक्स पुणे द्वारा निर्मित है। सोलेक्स और हेलियोस दोनों ही UR सैटेलाइट सेंटर बेंगलुरु द्वारा निर्मित किए गए हैं। ASPX और PAPA स्पेस फिजिक्स लेबोरेटरी VSSC तिरुवनंतपुरम द्वारा निर्मित किए गए हैं। और अंत में मैग्नेटोमीटर लेबोरेटरी फॉर इलेक्ट्रो ऑप्टिक्स सिस्टम्स बेंगलुरु द्वारा निर्मित किया गया है। यह कोस्ट फेज जारी रहने वाला है। आइए इस अंतराल में आपको लिए चलते हैं इस मिशन से जुड़ी चर्चा में, जहां वरिष्ठ वैज्ञानिक हमारे प्रश्नों के उत्तर देंगे, और फिर इस चर्चा के बाद हम वापस आएंगे लाइव इवेंट्स में।
As we are in the low visibility region of the flight path, we take you to the discussion room where the key personnel connected with the Aditya-L1 will enlighten more on the payloads and details. Over to discussion room.
Welcome viewers. After India's made history with the Chandrayaan-3 moon launch, it has now set its eyes on the sun. These scientific breakthroughs back to back are like feathers on our country's hat. In fact, these celestial bodies are very important and are considered as sacred bodies in multiple global religions. The sun is the central body of our solar system. The world revolves around it, and it is a source of energy for all planets, including the Earth. Today, I'm joined by all the scientists who have played behind the scenes to make this project a grand success. And I'm Srinidhi, reaching out to you from the Satish Dhawan Space Center, Sriharikota. And today we'll be discussing about the impact and the benefits of the Aditya-L1 space mission. So today we are joined by Dr. Anil Bharatwaj, Director of PRL, Professor Annapurni Subramanian, Director of Indian Institute of Astrophysics, Dr. Sankara Subramanian, Principal Scientist of Aditya-L1 mission, Dr. Durgesh Tripathi, PI of SCYT, Dr. Dipankar Banerjee, Director of IRIS, Nainital, Dr. Satish Tampi, PI of PAPA, and Dr. Vipin K. Yadav, PI of Magnetometer, joining us today for a 25-minute fireside chat on the sidelines of Aditya-L1 launch. To start with the Principal Scientist and PI of SOLEX, Dr. Sankara Subramaniam, why is Aditya-L1 mission so important, and what are the objectives of this mission?
Thanks a lot. I mean, first of all, let me thank ISRO as well as the Government of India for providing a great opportunity for the solar and heliophysics community of the country. Both solar, heliophysics as well as astronomy thrives on data. More the data you have, we get more understanding about the system. And Sun is our own star, our dearmost star, so understanding them is much more important for our everyday life. So this mission, Aditya, when it was conceived initially, with a support from our Professor U.R. Rao, along with Dr. Srikumar and Professor G. Srinivasan, we made sure that we will have a unique data set which is not available from any other missions internationally. So the 7 payloads, what was conceived for this particular mission, will provide a unique set of data which is currently not available from any other missions, which will provide us new insight into the solar and heliophysics community in India, and provides some important aspects like the initiation of the coronal mass ejections, the speed at which it gets initiated, and some wave bands which are very important for the Earth ionospheric connections, like near ultraviolet band, and the high energy particles, which is high energy radiations as well as particles which is coming from the solar flares and coronal mass ejections. So these are the informations which would be available from this particular mission, which will allow us to understand the sun, its dynamics, as well as the inner heliosphere, which is an important element for the current day technology as well as the space weather aspects of it.
Thank you so much for your remarks, sir. So now we'll move on to Dr. Anil Bharadwaj. So the sun is a very important energy source of life. Having understood that, it creates a trouble when it's angry. How does Aditya-L1 helps us through the mission?
Thank you and good morning, viewers. First of all, let me tell you that Aditya-L1 is a multi-wavelength, multi-instrument and multi-directional mission. Multi-wavelength because it works in X-rays, UV and visible. Multi-instrument because there are 7 experiments on board. And multi-directional because it looks not only in the sun direction but also around it. Now when the sun becomes angry, there are 2 types of process which happens. One is solar flares, that means electromagnetic radiation, which reaches the earth in 8 minutes. But along with that, there is a mass which is also ejected out in form of plasma, and that can take about 2 to 4 days to reach the earth. What we are looking for from the Aditya-L1 mission is to see the impact of solar flares as well as coronal mass ejections as they come to the earth. We have instruments which look at not only in the sun direction, but also in other directions, for example, perpendicular to ecliptic or in the earth directions. The impact is that we need to see when the sun becomes quite angry, what are the ways in which it is affecting the planet Earth, and L1 point being at point L1, which is just 1% away from the Earth, it is able to provide us a lot of new informations of the plasma and the electromagnetic radiations which is reaching the planet Earth.
Thank you so much, sir. So now we'll move on to Dr. Annapurni Subramaniam. So the science behind this mission is very unique. So what's the impact of this on the Earth and also on the heliosphere?
Yeah, so thank you for having me on this show. To put the thing in context, I'm the director of Indian Institute of Astrophysics, and we have delivered one of the major payloads on this mission. This is the visible emission line coronagraph. So if you actually look at the words used in it, it is visible because it is seeing the sun and the visible wavelength. Emission line, so what is it detecting? It is the emission line of certain elements. Because the corona is hot, the emission which you get is in the terms of, it's not absorbing the light which is coming from the sun, but it's already hot, so it is coming down by emitting lines. So we are tracking these lines using what? A coronagraph. Now what is a coronagraph? This instrument makes a total solar eclipse all the time within the instrument. So you are looking at the sun all the time, 24/7, through using this mission. And this instrument looks at the sun as though it is always in total solar eclipse.
The skies
now, why you want to have the eclipse all the time? Because you want to see the corona. Why corona? Because when sun burps, when sun is angry, The corona is
for
what
the flight
it takes
of
the matter away.
PSLV-C57
Now, what is unique about
Aditya-L1
this
mission.
instrument? This is going to see the corona as close as possible from the disk of the sun. Now,
We have
what is
4
so
minutes,
challenging about it?
23 seconds to the launch.
It is because the sun's corona is 1,000,000 times fainter than the disk of the sun. So you have to not see the disk of the sun,
सभी
but see
वैज्ञानिक
only the
अपनी
corona.
कंसोल पर
So this
आंकड़े
instrument is
देखते
very
हुए
difficult to make,
सभी
challenging,
तंत्र
but it is
सामान्य
made. Now it's
निष्पादन
going to
कर
the
रहे
orbit.
हैं।
Now what we planning to study
हम
using this
4
instrument
मिनट की दूरी
is
पर हैं
the
उड़ान से।
corona, its dynamics.
T-minus
Through this
4
emission
minutes
line,
and
you can
counting.
actually measure the velocity by simple physics called Doppler effect. So you can measure the velocity, you can measure how much matter is moving, and eventually how that matter will come to the Earth and the heliosphere. So it's overall this instrument, along with the others, of course, the other PI will also be explaining about it.
इसका मतलब
So these
PSO
holistically will
को
give you a lot
प्रथम
of
पोस्टिंग
information
फेज के बाद
regarding not
प्रज्वलित
only the
किया
sun, but
जाएगा,
also the
फिर
heliosphere.
30 सेकंड
Thank you.
प्रज्वलित रहकर
That was
यह
very
बंद हो
interesting,
जाएगा।
Doctor. Thank you
फिर
very
करीब
much.
1600
And now
सेकंड की
we'll move on
पोस्टिंग
to
फेज जारी रहेगी।
Durgesh Tripathi,
तत्पश्चात
Dr. Durgesh Tripathi.
फिर से
You are the PI
PS4
of
को
the
प्रज्वलित
payload
कर
for the
472
payload
सेकंड
suit.
तक प्रणोद
How
उत्पन्न
is that
किया जाएगा।
different from other
और फिर
telescopes
शांत
like
हो जाएगा।
Hubble or James Webb?
L1 के कक्षा
And what are you
की
going to
स्थिति प्राप्त
investigate
होते
using
ही
this?
उसे निर्दिष्ट कक्षा में
My voice is going to
प्रक्षेपित किया
mumble by,
जाएगा।
because I'm still in the awe of the
इस तरह
launch and
पूरे
all the
मिशन
payload
में
is gone there.
लगभग
So
3800 सेकंड का समय लगेगा।
essentially, JWST, which is James Webb Telescope, and the Hubble Telescope, they are going to look at the universe, different objects, galaxies, star
T-minus 3
formation,
minutes and
and
counting.
other objects you see in the universe. Whereas when we talk about Aditya-L1, it is going to look at one particular object, which is our sun. And it's
यह
also
PSLV-C57
kept on the
का
other
प्रमुख
side of the
यान
sun or
ट्रैकिंग
plane
के
at
संदर्भ
one
में भी
point,
काफी
whereas
जटिल
the
है।
James Webb
इसे ट्रैक
Telescope
करने
went
के
on
लिए
the other
शार,
side
पोर्ट
of the
ब्लेयर,
Earth, which
ब्रूने
is
और बैक स्थित ग्राउंड
at the
स्टेशन
L2
हमें
point.
वास्तविक समय पे
Now,
यान की
the
जानकारी
scientific
उपलब्ध
difference,
कराते
of course,
रहेंगे।
they also observe in ultraviolet, but
लेकिन चतुर्थ चरण के
Aditya,
प्रज्वलन
as
के समय यान
Professor
हमारे
Anil
ग्राउंड
Bharadwaj
स्टेशन
and
की
also
दृष्टि से
Professor
दूर जा चुका
Anupam
होगा,
alluded to,
इसलिए
these are
शिपबोर्न ट्रैकिंग
multi-wavelength
टर्मिनल को दक्षिणी पैसिफिक
satellite,
महासागर में
and they will be
स्थित किया
observing
गया
all
है।
across the
वह हमें
electromagnetic
PS4 बर्न 1
spectrum.
और बर्न 2 की
In
जानकारी
particular,
उपलब्ध कराएगा।
suit is going
इसके
to
बाद
be looking
PS4
at
शट
the
ऑफ और
ultraviolet
आदित्य-L1
radiation
के
in
अंतःक्षेपण
2000
की
to
पुष्टि
4000
कुरु
angstrom,
फ्रेंच
if
गयाना
that
स्थित
matters to
ग्राउंड
you,
स्टेशन से की जाएगी।
emits from the lower and the middle atmosphere of the sun. And what we want to look at that how in general the sun's atmosphere is coupled by looking at the observations at various height, and
T-minus 2
how
minutes and
actually this
counting.
radiation is coming and getting absorbed in the Earth's atmosphere, and what kind of effect it can have in the chemistry of
उड़ान
ozone
से
and
1
oxygen,
मिनट
for
50 सेकंड की
example,
दूरी
and
पर
also these explosions which are happening,
यह
how much
PSLV
radiation
की
they are
59वीं
creating,
उड़ान होगी
and how much
और
effect it would might
इस
have.
PSLV एक्सेल
Thank you very
संस्करण
much,
में
sir.
यह 25वीं
And now
उड़ान
we
है।
move on
इसरो के
to
वर्क हॉर्स
Dr.
कहे जाने
Satish
वाले इस
Thampi.
रॉकेट कई
You are
ऐतिहासिक
connected with the
मिशन
payload
को
Papa.
सफलतापूर्वक संपन्न किया है,
Already the
जिसमें
plasma
चंद्रयान
particles
1
on the
और
moon
मार्स
are
ऑर्बिटर
analyzed.
मिशन
How do you
उल्लेखनीय है।
analyze plasma
यह
particles
प्रमोचन
in the
वर्ष
sun?
2023
And what is
का
the
7वां मिशन होगा।
importance of solar winds
इस
and how
साल
does
की
it
शुरुआत
impact?
में SSLV के सफल प्रमोचन से शुरुआत
Thank
कर
you for
LVM-3
giving
के 2
an
प्रमोचन,
opportunity to
GSLV
come to
Mark
this
2 का
role.
एक और
As my colleagues they
PSLV
mentioned
के
actually
2
about the
सफल
sun.
प्रमोचन हो चुके
Today
हैं।
we have the
यह
auspicious
PSLV
day where actually we are going to
का
our own
वर्तमान
star,
वर्ष
that
में
is the sun.
तीसरा मिशन है।
Just I want to tell to the viewers that actually the sun, which is our hero basically in the solar system. If you look into the mass of the solar system, 99% of the mass of the solar system is occupied by sun. And also this sun is plasma.
Minus
Now when
55
we are
seconds.
talking about the heliosphere, actually with this all our planets are engulfed in that thing.
Minus 50 seconds.
You know, we have been studying in decades, maybe in centuries, we have been studying about the sun. But what we are lacking actually a
हमारे साथ बने
comprehensive approach,
रहिए।
because sun is giving its energy mainly in three
40
forms.
सेकंड पर
The first one is the radiation, actually my colleagues
प्रमोचन
already
किया
talked,
जाएगा।
which we can do remotely from our ground.
Minus
But
35
the
seconds.
plasma, basically we are talking about the solar wind, what we call the space plasma, as well as the magnetic
Minus
field.
30 seconds.
This can be only studied by in situ. If we study all these radiation, particles
Minus
and
25
fields, then only we will get a full
PS2,
comprehensive
PS2
understanding of
open.
the sun. Now, we are getting the
Minus
first
20
space-based
seconds.
observatory from the Indian soil,
PSL
and
English
we are
normal
making this
now.
opportunity.
Minus
And of
15
course, I am
seconds.
thankful to ISRO and all my colleagues and my teammates from VSSC and all my scientific colleagues
10,
here. This
9,
is the opportunity we got
8,
actually. We are trying to
7,
understand
6,
actually all the three
5,
fields, radiation, particles,
4,
and field. Already they
3,
mentioned about the radiation. Now, Dr. Bivin will be talking about field. Just I want to emphasize on the particles. That's why we named it. Papa means
2, 1, 0. Plus 5 seconds. Lift off normal.
P1 tracking. P3 tracking.
Magnificent liftoff of PSLV-C57 with Aditya-L1 on board.
Plus 15 seconds.
PSLV-C57 का सफल उत्थापन और इसके साथ
20 seconds.
प्रथम भारतीय सौर अंतरिक्ष यान निकल चुका है सूर्य के तेज से विज्ञान को प्रकाश करने। इसके साथ ही एक और कदम है अंतर्ग्रहीय सफर में भारत की उपस्थिति सिद्ध करने का। आप देख रहे हैं PSLV-C57 प्रथम चरण पूरी तरह सामान्य।
The rocket flying forth, following nominal trajectory and developing nominal thrust. The bright fumes against a clear midday sky. A rocket launch is more than just a sight to behold. The roaring sound and the vibrations that we can feel here, adding to this, the thrill, are just amazing. Ground-lit and air-lit strap-ons operating together with the first stage, S139.
Ground-lit strap-on separated.
जैसा कि निर्धारित है ग्राउंड लेड स्ट्रैप ऑन को सेपरेट कर दिया गया है और प्रथम चरण का निष्पादन सामान्य है। इस घटनाक्रम में अगला एयर लेड स्ट्रैप ऑन को यान से पृथक कर दिया जाएगा।
एयर लीड स्ट्रैप ऑन सेपरेटेड।
जी हाँ, इसकी भी पुष्टि हो गई है। स्ट्रैप ऑन को सफलतापूर्वक पृथक कर दिया गया है।
We are 100 seconds past the launch time. The ground lit and air lit strap ons have been separated. S139 motor still thrusting.
S139 110 सेकंड के प्रज्वलन काल के पश्चात उसे भी पृथक कर दिया गया है।
Plus 2 minutes.
द्वितीय चरण जो कि तरल नोदक पर आधारित चरण है, इसका प्रज्वलन शुरू हो चुका है और वर्तमान में प्रणोद उत्पन्न कर रहा है।
The launch vehicle is at an altitude of 73 kilometers. First stage has been separated, second stage has begun its operation, and the closed loop guidance has been initiated. According to the announcement by Range Operations Director, PS2 is developing nominal thrust.
PS2 41 टन के तरल नोदक पर आधारित चरण है। इसमें विकास इंजन द्वारा 800 किलो न्यूटन का प्रणोद उत्पन्न होता है और इसका प्रज्वलन काल लगभग 150 सेकंड का होगा।
SHAR and Port Blair tracking stations presently acquiring signals. Flight path closely matching the prediction.
Plus 3 minutes.
वर्तमान में यान क्लोज लूप गाइडेंस के अंतर्गत है।
Second stage performance normal.
यान की ऊंचाई 106 किलोमीटर तथा सापेक्ष गति 3 किलोमीटर प्रति सेकंड।
The velocity addition in PS2 regime is going to be from 2 kilometers per second to 4.9 kilometers per second.
Payload fairing separated.
The payload fairing covering the Aditya-L1 spacecraft has been separated. The current altitude of the launch vehicle is 118 kilometers. Relative velocity exceeding 3.8 kilometers per second.
जी हाँ, यान अब घने वातावरण से बाहर जा चुका है, इसलिए ऊष्मा कवच की जरूरत नहीं रह जाती है और इस कारण इसे यान से पृथक कर दिया जाता है।
Second stage performance normal.
द्वितीय चरण वर्तमान में प्रणोद उत्पन्न करता हुआ और यान पूरी तरह सामान्य प्रदर्शन करता हुआ अपने अनुमानित पथ की ओर बढ़ रहा है।
Second stage separated, third stage ignited.
द्वितीय चरण को भी सफलतापूर्वक यान से पृथक कर दिया गया है उसके प्रज्वलन काल समाप्त होने पर। और तृतीय चरण जो कि ठोस नोदक पर आधारित चरण है, इसका प्रज्वलन शुरू हो चुका है।
We are close to 5 minutes past the launch time. Presently, the third stage of PSLV is operational, developing nominal thrust.
Plus 5 minutes.
तृतीय चरण में 7.6 टन के ठोस नोदक का प्रयोग होता है। और इसका प्रज्वलन काल 117.7 सेकंड का होगा। इस दौरान यह 240 किलोन्यूटन का प्रणोद उत्पन्न करेगा। वर्तमान में यान की ऊंचाई 134 किलोमीटर तथा सापेक्ष गति 5.96 किलोमीटर प्रति सेकंड। जैसा कि हम जानते हैं PSLV सबसे विश्वसनीय रॉकेट रहा है इसरो का, वैसा ही प्रदर्शन करता हुआ एक और मिशन PSLV-C57 का।
For the present mission, after PS3 completes its burn duration, a coast phase of 200 seconds will follow, in which the rocket will continue to be steered while there is no development of thrust.
जी हाँ, अभी कुछ ही क्षणों में PS3 का प्रज्वलन काल समाप्त हो चुका है और कोस्टिंग फेज इसके बाद जारी रहेगा।
Vehicle in combined hosting for approximately 200 seconds.
Unique to this mission, the PS4 will start twice at predesignated times and duration. The multiple start capability of PS4 will be utilized very aptly to achieve the argument of perigee of 346.6 degrees, which is very crucial for this mission. The commencement and duration of PS4 burns enable achieving this orbital parameter. Argument of perigee is the angle that is made by the perigee point from the ascending node at equatorial plane. AOP exceeding 300 degrees is helpful in mission planning to achieve halo orbit around L1 with minimal propellant expenditure.
सभी वैज्ञानिक गहनता से अध्ययन करते हुए इन आंकड़ों का, जो कि ग्राउंड स्टेशन द्वारा प्रसारित किए जा रहे हैं। वर्तमान में PS3 PS4 कंबाइंड कोस्टिंग फेज जारी है। यान की ऊंचाई 170 किलोमीटर तथा सापेक्ष गति 7.32 किलोमीटर प्रति सेकंड है।
Vehicle performance normal. Plus 9 minutes.
Speaking a few words about the Aditya-L1, describing the sun, Indian Vedas have said, Yesha Bhagavan Manirakasha Mandalasya Chakravati Khechara Chakrasya Deepako Brahmanda Bhandasya Asayeva Charkarti Bharvati Charhati Jagat. This mighty jewel, the light of eastern sky, who generates, operates and destroys the universe, while the energy of sun, after having filtered by the atmosphere, is available for the sustenance of earth. The explosive phenomena in sun and the solar flares are a cause for concern to the spacecraft and human space missions. The vantage point for such observations is a place in between the sun and earth.
Third stage separated.
Now we have a successful separation event of the third stage of PSLV.
It is approximately 900 seconds.
Plus 10 minutes.
जी हाँ, तृतीय चरण को सफलतापूर्वक पृथक कर दिया गया है और अब PS4 कोस्टिंग फेज पर है। इस दौरान कोई भी प्रणोद उत्पन्न नहीं हो रहा है। यान प्राप्त संवेग से आगे बढ़ता हुआ और निर्धारित पथ का अनुकरण करता हुआ जा रहा है।
We are 627 seconds from the launch. For another 600 more seconds or so, we will be getting tracking data from the BIAX ground station.
यह कोस्टिंग फेज लगभग 900 सेकंड का होगा। इस दौरान हम आपको कुछ जानकारी देते हैं। लैग्रेंज पॉइंट से जुड़ी कुछ रोचक तथ्य भी हैं, जैसे कि इस पॉइंट का नाम एक इटालियन फ्रेंच गणितज्ञ जोसेफ लुइग लैग्रेंज के सम्मान में रखा गया था। उन्होंने 1972 में इसे अपनी तकनीकी प्रपत्र जनरल 3 बॉडी प्रॉब्लम में वर्णित किया है, लेकिन इससे पहले भी 3 पॉइंट L1, L2 और L3 को खोजने का श्रेय स्विस गणितज्ञ लियोनार्ड आयलर को जाता है। L1 पॉइंट पर नासा ने पहले ही सोलर एंड हेलियोस्फेरिक ऑब्जर्वेटरी सोहो को पहुंचा चुका है और विश्व प्रसिद्ध जेम्स वेब टेलीस्कोप को L2 लैग्रेंज पॉइंट पर स्थापित किया गया है। L1 की पृथ्वी से सूर्य की दिशा में दूरी लगभग 15 लाख किलोमीटर है और इसे हम एस्ट्रोनॉमिकल यूनिट में 0.01 एस्ट्रोनॉमिकल यूनिट कह सकते हैं। यह पृथ्वी से सूरज की दूरी का केवल 1% है।
The vantage point for observing sun is a place in between the sun and earth where direct visibility exists to
in the country. We are regularly conducting workshops. So through these workshops and training program, we really want to reach out to that the youngsters, that the next generation will come and utilize this data, because the data is for the community. So unless we have more users, we will not be able to effectively utilize the data, scientific data which is coming, and the way we can help the community at large. Thank you.
Thank you very much, sir.
I think it is very important for us also to reach out to schools and colleges, because the younger generation should be told about this kind of activities which is happening in the country. Chandrayaan 3 launch has galvanized the whole nation, and everybody is interested to know what all is happening in the science and technology within the country. And therefore, this mission, along with the Chandrayaan 3 mission, that is the Aditya-L1 mission and Chandrayaan 3 mission, is going to give us a lot of new information which is going to be very beneficial for the country. Thank you. Thank you very much.
Thank you everybody for participating in this discussion. And now we move on to the control room.
Thank you, Srinidhi, and I thank all the panelists for enlightening us about the high-tech science that Aditya-L1 is about to do.
जी हाँ, अभी आपने सुना इसरो के तथा अन्य संस्थानों के वरिष्ठ वैज्ञानिकों ने हमारे बहुत महत्वपूर्ण सवालों के बहुत ही रोचक उत्तर दिए हैं। इस दौरान चतुर्थ चरण के बर्न 1 को कंफर्म किया गया है फिजी टेलीमेट्री स्थित स्टेशन से। इसमें यान में होने वाले त्वरण के बदलाव को मापा जाता है और इससे पता लगाया जाता है कि यान के इंजन में शुरुआत हुई थी या नहीं, और इसकी पुष्टि कर ली गई है। लेकिन अभी भी यान हमारे दृष्टि से बाहर है, हमारे ट्रैकिंग रेंज से बाहर है, लेकिन इसकी यात्रा अभी जारी है। और अब हम स्क्रीन पर देख पा रहे हैं, यह पूर्वानुमानित पथ दिखाया जा रहा है। यह अनुमानित पथ है। ग्राउंड स्टेशन से पुष्टि होने के पश्चात यहाँ पर इसकी पुष्टि की जाएगी। आज 11:50 पर प्रमोचित हुए PSLV-C57 रॉकेट की यात्रा अभी भी जारी है। प्रथम, द्वितीय तथा तृतीय चरण के सामान्य कार्यकाल के पश्चात इन्हें यान से पृथक कर दिया गया था। और
shipborne
फिर
terminal acquires telemetry signal.
जी हाँ, इसकी पुष्टि शिपबॉर्न टर्मिनल से हमारे यान को ट्रैक कर लिया गया है।
At present, ground trace and FPD are updated based on real-time data.
अब हमारे ग्राफ को वास्तविक समय से दिखाया जा रहा है। यह वास्तविक डेटा है जो अब हम देख पा रहे हैं।
Welcome back to the live coverage of PSLV-C57 Aditya-L1 mission. The launch took place at 11:50 hours Indian Standard Time from the second launch pad at Satish Dhawan Space Center, SHAR, Sriharikota. The first, second and third stage of the launch vehicle have performed normally, and the launch vehicle was in the no visibility range for the ground tracking stations. Shipborne terminal in Pacific Ocean has started to acquire signal 51 minutes into the flight.
अब कुछ ही क्षणों में हम चतुर्थ चरण के पुनः प्रज्वलन को देखेंगे।
In the past 26 minutes or so, the ground trace for the flight was being updated by extrapolation.
Fourth stage engine started for band 2.
यहाँ अभी अभी रेंज ऑपरेशन डायरेक्टर ने इसकी पुष्टि की, चतुर्थ चरण का प्रज्वलन शुरू हो चुका है। यह पुनः प्रज्वलन है PS4 का कोस्टिंग फेज के पश्चात। यह वास्तविक समय पे हमें यहाँ आंकड़े उपलब्ध हो रहे हैं क्रूज स्टेशन से।
Very happy piece of news here.
Normal.
Range Operations Director has confirmed the second burn commencement for the PS4 stage. Around 14 more minutes to go for the spacecraft injection.
जी हाँ, अभी भी लगभग 14 मिनट बाकी हैं हमारे अंतरिक्ष यान आदित्य-L1 को अंतक्षेपण के लिए। आपकी जानकारी के लिए बता दें कि इस कालावधि जब अंतरिक्ष यान या हमारा यान हमारी दृष्टि से दूर हो जाता है, इस कालावधि में ग्राउंड स्टेशन की दृष्टि से बाहर जा चुका होता है और यान के ऑन बोर्ड कंप्यूटर पर टेलीमेट्री स्टोरेज पर यान के महत्वपूर्ण आंकड़े सेव किए जाते हैं। जब यह हमारे तय ग्राउंड स्टेशन की रेंज में आते हैं तब इन आंकड़ों का प्रसारण होता है और वहां से इनकी पुष्टि की जाती है कि यान इस दौरान किन गतिविधियों से गुजरा।
Fourth stage performance normal.
The fourth stage performing normally. The second burn is expected to last for 472 seconds.
यह चतुर्थ चरण है PSLV XL रॉकेट का। इसमें 2.5 टन के नोदक का इस्तेमाल हो रहा है। यह तरल नोदक हैं। इसमें 2 इंजन लगे होते हैं, हर एक 7.33 किलो न्यूटन का प्रणोद उत्पन्न करता है। इस तरह कुल प्रणोद 14.6 किलो न्यूटन का होता है।
Plus 55 minutes.
इस प्रज्वलन काल में इसे 472 सेकंड तक प्रज्वलित रखा जाएगा। वरिष्ठ गणमान्य व्यक्ति यहाँ उपस्थित हैं।
We are close to 55 minutes 30 seconds past the launch. PS4 stage currently burning for the second time.
Stage performance normal.
Intended trajectory closely matching the prediction. Presently the shipborne terminal is acquiring the signal. Few seconds later there will be another no visibility phase before Koru starts to acquire signal.
जी अभी द्वितीय बर्न चालू है PS4 स्टेज का। अभी कुछ 200 और सेकेंड जलकर यह शांत हो जाएगा। सूर्य एक बड़ा और हमेशा से एक समीप का सितारा रहा है हमारे लिए। असल में यह गर्म आग का गोला है जो अनगिनत हाइड्रोजन एटम्स के फ्यूजन रिएक्शन से ऊर्जा प्राप्त करता है और इस ऊर्जा से इस सौर मंडल को एक परिवार की भांति समेटे हुए है। पृथ्वी से सूर्य की दूरी लगभग 150 मिलियन किलोमीटर है। सूर्य ही हमारी ऊर्जा स्रोत है और इस जीवन जो हम जानते हैं उसका भी स्रोत है।
Loss of signal for shipborne terminal. The next telemetry station is Kuru. The telemetry signal break will be approximately 205 seconds. During this non-visibility period, ground trace and flight parameters will not be updated.
यान फिर से अंतर्दृष्टि हो चुका है, हमारे ट्रैकिंग रेंज से बाहर है। अगला ट्रैकिंग स्टेशन कुरु स्थित फ्रेंच गयाना स्थित कुरु स्टेशन से हमें आंकड़े उपलब्ध होंगे कुछ ही समय में।
After being injected into the space, the Aditya-L1 will not travel directly to the L1 point. Transfer maneuvers will be performed to position the spacecraft in a halo orbit. Aditya-L1 will first be made to perform maneuvers in Earth orbit. Adjustments will be made in its orbital parameters. After ascertaining the normalcy of the craft, its systems, payloads and the orbital parameters, burn to exit Earth's sphere of influence will be initiated. After exit from SOI, the cruise phase will start and subsequently the spacecraft will be injected into a large halo orbit along L1. The total travel time from launch to L1 will take about 4 months for Aditya-L1.
इस दौरान आइए आपको अवगत करा दें आदित्य-L1 के मुख्य उद्देश्य से। आदित्य-L1 मिशन का मुख्य उद्देश्य है सौर गतिविधियों के विभिन्न पहलुओं में महत्वपूर्ण जानकारियां उपलब्ध कराना और इन गतिविधियों का अंतरिक्ष मौसम के असर का अध्ययन करना। इस कार्य के लिए इसमें 7 भार लगे हुए हैं जिनकी मदद से आदित्य-L1 फोटोस्फीयर, क्रोमोस्फीयर और सूर्य के बाहरी परत के विभिन्न वेवलेंथ में प्रेक्षण कर सकेगा। विशेष वैज्ञानिक उद्देश्य इस प्रकार हैं: सूर्य के ऊपरी परत जिसे हम कोरोना के नाम से जानते हैं इसके गतिकी का अध्ययन करना, क्रोमोस्फीयर और कोरोनल तापमान, आंशिक रूप से आयनिक प्लाज्मा की भौतिकी, कोरोनल मास इजेक्शन की शुरुआत और फ्लेयर्स का अध्ययन, सूर्य के कण की गतिशीलता के अध्ययन के लिए आंकड़े प्रदान करना और यथास्थिति कण और प्लाज्मा वातावरण के प्रेक्षण करना।
+1 hour.
वर्तमान में आरओडी ने घोषणा की।
Thrust cutoff after band 2.
अब चतुर्थ चरण को बंद कर दिया गया है, अब उसका थ्रस्ट कट ऑफ कर दिया गया है और वह बंद हो चुका है।
Injection conditions are achieved.
और इसकी भी पुष्टि हो चुकी है कि आदित्य-L1 के अंतःक्षेपण की स्थितियां प्राप्त की जा चुकी हैं।
We are now eagerly awaiting the injection of the satellite, as we have the confirmation from the Range Operations Director that the thrust cutoff for 4th stage of PSLV has been achieved. We are 1 hour into the flight.
कुछ ही क्षणों में कुरु स्थित ग्राउंड स्टेशन से इसकी पुष्टि की जाएगी।
Highly anticipated event next is the separation event of Aditya-L1 spacecraft.
यान अपने निर्धारित कक्षा की ओर, कुछ ही क्षणों में इसकी पुष्टि होनी बाकी है। यान से अंतरिक्ष यान आदित्य-L1 का सफलतापूर्ण अंतःक्षेपण अभी बाकी है।
For Aditya-L1, ISRO has developed advanced flight dynamic software to obtain past trajectory data from tracking, apply mathematical computation to calculate present and future location of the spacecraft in a process known as orbit determination. But the correct orbital parameters at the time of injection are of prime importance.
अब तक कुल 22 सौर मिशनों को नासा, ईसा, जर्मनी
Aditya-L1 satellite separated.
और जिसका इंतजार था वह पल आ चुका है, इसकी पुष्टि कर दी गई है। Aditya-L1
mission accomplished, handing over to mission director.
And we have a confirmation of Aditya-L1 separation. The mission has been accomplished.
PSLV-C57 has injected Aditya-L1 satellite into the desired intermediate orbit. PSLV-C57 Aditya-L1 mission is accomplished.
आदित्य-L1 को पूर्ण परिशुद्धता से इसके निर्धारित कक्षा में स्थापित कर दिया गया है। इसके बाद वह अपने आगे की सफर जारी रखेगा L1 पॉइंट के लिए।
Do join us for the address by Chairman ISRO, Secretary Department of Space, Shri S. Somnath.
सभी दर्शकों को शुभकामनाएं और बधाइयां इस मिशन की सफलता के लिए। अब हम आपको लिए चलते हैं अध्यक्ष महोदय के एड्रेसिंग के लिए।
Congratulations. The Aditya-L1 spacecraft has been injected in an elliptical orbit of 235 by 19,500 kilometers, which is intended very precisely by the PSLV, very unique mission mode here, with the upper stage of the PSLV taking two-burn sequence for injecting the primary satellite for the first time. So I want to congratulate PSLV for such a very different mission approach today to do this mission of Aditya-L1 to put it in the right orbit. Now, from now, the Aditya-L1 will take its journey after some Earth maneuvers. It will start its journey to the L1 point, a very long journey of almost 125 days. So let us wish all the very best to Aditya spacecraft for its long journey and being put around the halo orbit of L1. So with me, the mission executives are there. Mr. Biju, the mission director, and Nigar Shahji, the director of the satellite project. So let them join me. Our Honorable Minister of State for Science, Technology and Space is here, Dr. Jitendra Singh, so I request him to speak a few words.
Congratulations, India. Congratulations, ISRO. And while the whole world watched this with bated breath, it is indeed a sunshine moment for India. Thank you, Honorable Prime Minister Narendra Modi ji, for making this happen by opening up new vistas for India's space sector and telling us that sky is not the limit. Thanks also, Honorable PM, for giving us the confidence, the courage and the conviction to reach out to the stars and to discover the mysteries of universe beyond. And thanks also for making us realize the enormous potential of our space fraternity. Ladies and gentlemen, Indian scientists had been working, toiling day and night for years and years together, but now comes the moment of vindication, the moment of redeeming the pledge to the nation. And coming close on the heels of successful Chandrayaan-3 landing, the successful launch of Aditya-L1 is also a testimony to the whole of science and a whole of nation approach which we have sought to adopt in our work culture. While ISRO is credited in executing this mission, the science institutes across the country have come forward to contribute in one form or the other, in small measure or big, to this mission. To name a few, the Indian Institute of Astrophysics, Bengaluru, the National Aerospace Laboratories, the Tata Institute of Fundamental Research, Mumbai, the Nijri NGRI, Nagpur, the IIT Kharagpur, IIT Madras, IIT Delhi, IIT Mumbai, and the list is too long. But that, having said that, gives me the confidence to say that this day, the 2nd of September 2023, is a day of reckoning when we move on into the next 25 years of Amrit Kal, and Mother India pledges with the collective will and collective effort of our 140 crore children to reach and occupy the place of pride on the world pedestal. Congratulations once again, Chairman Somanath, the entire ISRO team, and the entire countrymen.
May I request the project director of Aditya-L1, Nigar Shahji, to say a few words.
Good afternoon. It's a dream come true for Team Aditya-L1, and I'm extremely happy that Aditya-L1 is injected in the intended orbit flawlessly by PSLV as always. And Aditya-L1 solar panels are deployed, and the spacecraft will be normal. And Aditya-L1 has started its 125 days of long journey towards L1. We have our Earth burns to rise the orbit, and followed by the trans-L1 injection, and finally insertion into the halo orbit in the Sun at Lagrange point L1. Once the Aditya is commissioned, it will be an asset to the heliophysics of the country and even to the global scientific fraternity. And I take this opportunity to thank Chairman ISRO, Director URSC, former Director URSC, and all the center directors for their support and guidance for making this mission possible. And my thanks are due to my project team and all the project executives across the center, payload teams, especially the teams from the IAA and IUCA, for the relentless effort in building the payload as well as the spacecraft. And my special thanks to the expert committee who have been guiding all through the entire project life cycle. And I thank all the industrial partners and the entire URSC team for their invaluable contribution. And I feel really honored and privileged to be part of this mission. And at this juncture, I would like to remember Professor U.R. Rao, who sowed the seed for this mission, and looking forward for a successful halo orbit insertion and further great science output from the Aditya-L1 mission. Thank you all.
Sri Biju, the mission director and the project director of PSLV.
Good afternoon to all. My big salute to all of you for achieving this wonderful mission of Aditya. We have injected Aditya in its intermediate orbit. PSLV in its 59th mission has successfully accomplished injecting Aditya-L1 in its intermediate orbit. It's all because of the dedicated effort of all of you. The challenging requirements given by satellite team was indeed very it was very challenging to meet the orbital requirements. We have gone for a new mission design strategy. We have gone through numerous simulations to validate this, and that is the proof that you are having now. I take this opportunity to thank each and every one of you for achieving this wonderful mission. I take this opportunity to thank all my review forums, chairman and members of all review forums, and our industry partners for giving high reliable systems for PSLV, and all our family members. With this, our capability of PSLV has increased manifold to venture into new missions, to new and challenging missions. I take this opportunity to thank my project team led by our Sri M.J. Lal as well as Damodaran, Vehicle Director and Associate Vehicle Director, in leading the entire campaign. I wish our satellite team an excellent time ahead for completing all the operations and completing all scientific objectives they have envisaged. Thank you all. Thank you very much.
Thank you everybody for spending your time watching this mission and also supporting us and congratulating us, and we joined the entire country. We are very proud of the fact that we could do this mission, Aditya-L1 mission, just following the Chandrayaan-3 activities, and all of you are aware that the lander and the rover are still functioning, and our team is with the scientific instruments doing a lot of work now. And the good news is that the rover has moved almost 100 meters from the lander, and we are going to start the process of making both of them sleep in the coming 1 or 2 days, because it has to withstand the night. So until we hear about them later, so I would like to say big thanks to each one of you for the support and encouragement and blessings that you are giving to us for continuing the work of building the very strong space infrastructure and capability for India, and which will be becoming one of the strong pillars of science and technology for this nation. And thank you so much for the contributions once again, and wish you all the best for meeting you for next mission from Satish Dhawan Space Center. Thank you. contribution from across the center, this could be done. So let me start with the Director VSSC.
Good afternoon, India. So this is the 59th mission of PSLV, and 1993 was the first mission. So this is the 30th year of PSLV. So it's PSLV is on the threshold of Shashti Purti. With the next launch, it will be crossing, will be making 60th launch. I wish all the very best to the satellite team, all payload specialists for the operation of the payloads and satellite in coming days. And I'm take this opportunity.
National Research and Innovation Agency making a presentation, we request you to please take a seat here in front. And thereafter, Space Angel Australia and SABR in Australia. The presentations will be made, ladies and gentlemen, from this podium. We also have a clicker for your convenience. The clicker, the slide changer, as you can see, has a green button, which is to go ahead on your slides, and the red button is to go back, should you skip a slide. And the other thing that I have to announce is each presenter is going to get 3 minutes. We request you to please stay within time limit, and a buzzer will be sounded at the end of 2 minutes 30 seconds. So that will alert you when you have 30 seconds remaining. Additionally, there's going to be a timer running on the topmost right corner of your screen for you to assess time. Welcome back, ladies and gentlemen. We are now starting with the Space Business Connect session. In this session, we have actually invited overseas and Indian companies to make a pitch about their companies. We have a total of 49 companies as well as 2 industry associations whose representatives are going to be making a pitch presentation. As I said earlier, we request each speaker to be brief and complete their talk in under 3 minutes. Before we begin with the pitch presentation session, we'd like to extend a very warm welcome to Dr. Pavan Goenka, Chairman InSpace, who's going to be chairing this session. We extend a very warm welcome to Mr. Somnath S., Secretary, Department of Space and Chairman ISRO, seated on the head dais. And we also extend a very warm welcome, ladies and gentlemen, to Dr. Vinod Kumar, Director Promotion InSpace, and Mr. Shantanu Bhattavdekar, who's the Scientific Secretary of Indian Space Research Organization. Let's extend a hand and welcome the dignitaries in our midst. And I extend a very warm welcome to all the distinguished delegates. And ladies and gentlemen, with that, I would first, of course, request Dr. Pavan Goenka, Chairman InSpace, to do the opening remarks. Can we have the microphone on, switched on the dais, please?
Good afternoon, everyone. Secretaries, DOS, and my other colleagues here. Welcome to the grand finale of a hectic 2 days of schedule. And as was mentioned by Swarya, that we have about 50 people who will be presenting their pitch on their company. And this will be a Guinness Book of World Record probably for 50 people to finish their talk in 2.5 hours. And that too engineers and scientists and business people. So no politicians though. So so let's see how we manage that. But let me just say it's in a way continuation of what we talked about in the morning, where we talked about what each country is doing, and now we are talking about what some of the companies are doing. We have a very good lineup of companies that will be making the presentations. And I think you will find, as I looked at some of the presentations, that fair amount of work is happening all over the world, something that none of us perhaps have a full view of. And when we go through this impressive presentation, we will really realize that private sector has come of age when it comes to the space sector. I'm going to request my colleague.
Ladies and gentlemen, very good afternoon. On behalf of G20 SELM Organizing Committee, I extend a warm welcome to all of you to this amazing Space Business Connect session. During this session, this presentation are planned by global space industry. It is indeed a very significant day as we gather here to witness the cutting-edge innovation and capabilities of space industries from around the world. Friends, we are read a recent article in New York Times, explosive growth of Indian space tech startups. I am pleased to see that out of total 50 plus presentation, over 60% are from Indian industry. Your dedication, ingenuity, and relentless pursuit of excellence have positioned Indian space sector to be reckoned with within the global space community. Friends, the space industry with its ever-expanding opportunities has the power to transform not only the understanding of our universe, but also everyday lives of here on the earth. Under various verticals of space, I would like to express my gratitude to the G20 SELM Organizing Committee for this initiative. Your commitment to nurturing the space ecosystem is commendable, and we are privileged to have your unwavering support. The potential partnership that can develop here can propel your ventures to new heights. Without further ado, let us embark on this remarkable journey of limitless possibilities. Friends, new space era has begun. Thank you, and let the presentation begin. Please stick to the allotted time.